Yes, thank you to you, Shalom, and everybody else who's been organizing this event and the previous ones. It's really an honor to be able to be here today and speak with you all and present a little bit. So I'm from a small consultancy called Canastruc Conseil Service. So we specialize in Kotlin development. And one of the things we've been experimenting a lot with lately is Kotlin Multiplatform development. So today I want to share a few insights about that with you all. Oh, I should also say thanks to one of my own sponsors. Google are generous enough to help me with various travel expenses and things like that as a speaker. So I should mention them. Thank you to everybody involved in the Google Developer Expert Program. I appreciate, lots of appreciation for all the hard work the community is putting in, especially in virtual times. So enough about me. So about the subject. With modern application nowadays, targeting iOS, Android, and the web, they're basically table stakes now. So that can be really, really challenging if you're, like me, a small consultancy, and you have to work with very limited resources, right? So Kotlin Multiplatform promises to be a really nice solution to this kind of problem. It allows you to target mobile platforms and the web, not to mention server and all that good stuff as well. So as I mentioned, my small consultancy agency is called Canastruc. We decided to embrace Kotlin Multiplatform just because we believe that it helps us basically punch above our weight. So sharing a few insights about what we've learned so far with Kotlin Multiplatform. Now, the big strength, in my opinion, of Kotlin Multiplatform is it allows you to write native applications. So you can compare that with Flutter and React-Native, which allow you to write multi-platform applications as well, but basically only allow you to target one type of view system. So the big advantage with Kotlin Multiplatform is you're still writing native apps. So if you're on Android or Apple iOS, or you're using JavaScript to target the web, you use each of the native platforms' APIs, the latest and greatest, and you can keep your look and feel very consistent with the platforms. Now, that's a critical difference, right? But that's also potentially a small risk, and we'll talk about that in a minute. So the thing is that if you're targeting native frameworks, right, if you're using SwiftUI or Compose or React, the web version of React, that code that you're going to be writing will become single use, right? Even if it is written in Kotlin. So to get the most out of the code you write, it's helpful to put your efforts where they count the most. So I have a small chart here to sort of, spell that out for you. Now, the first one, the common Kotlin code, it's your best payoff. Whatever code you write in the so-called common modules of your Kotlin project, you're going to be able to reuse everywhere. Best payoff ever. Android, a bit different. This is where you're going to be digging for gold. So if you're writing your Android app, you have a nice Android app that already is set up and you've got your whole architecture going, then you'll be able to go in there and perhaps extract code and bring it into that common module I've been talking about. So that's a potential reuse you have right there. If you're targeting iOS, your UI code will be Swift or Objective-C, most likely Swift and SwiftUI nowadays. So that's technically single use, unless you decide that you want to use it as in a Mac OS application, which is a possibility. Then you have to close off JavaScript. So personally, when I write client code in Kotlin JS for the web, I find that my code is technically reusable across platforms and can be brought into the common module, a bit like my experience with Android. But the problem I found is that personally, you often end up writing code that's a bit polluted with web-only concerns. Since you're interacting a lot with the JavaScript layer and the DOM and things like that, the code is somewhat less reusable in my own experience, but that might be different for you if ever you experiment with that. Now, it's probably not a surprise here that I believe the architecture and the dependency engine that you're going to be using with your project really are core and critical to maximize your code reuse across the board. And this is why this talk is about MVI and Kotlin Multiplatform. My personal belief is that MVI will bring you a very nice exponential return on your efforts. You'll be able to use that code, a lot of the code, all across the board. So to get started on the right foot, though, it's time for me to explain what exactly is MVI and review some of the concepts with you. So unidirectional data flow is the basis of MVI. It's a deceptively simple concept. So the idea with MVI is that your view generates events. So when the users interact with the view, they press buttons, they generate what would be called a view event. Those view events you convert into something called an intent. An intent is a bit more abstract. It's detached a little bit from the view. It's a concept that you can take this intent and pass it on to the model. The model will receive this intent, update its own internal state, and in return, views subscribed to that model will update themselves accordingly. And once the view is updated, the user can interact again, and you start the loop over again. And this is the concept of the unidirectional data flow. Now, another critical principle of MVI is that models use an immutable state. Now, that's a big one. We rely on data classes here since they enforce immutability very naturally. Now, the benefit of using data classes is that when you have view code that, say, would try to manipulate or directly mutate a model, that code simply can't compile. You can't do that, right? Like the val counter here is immutable, and so you'll be forbidden from doing effectively an illegal operation. If direct state mutations were allowed from the view code, other views couldn't find out and they wouldn't refresh. You'd get an instant bug. So you don't want that. Immutability is important, and effectively it's because you want to avoid ending up with shared mutable state. So whenever you have data persisted over time, that can be modified and that is accessible concurrently, then you have shared mutable state. Now, it often comes up as effectively the root of all evil in many programming circles. Shared mutable state will make your code unpredictable, hard to understand, and really hard to test. You can think of shared mutable state as the close cousin to global variables. Now, avoiding shared mutable state is one of the functional programming principles that MVI adopts. So functional programming will promote instead the use of pure functions. Pure functions always return the same value for a given set of arguments, and they have no side effects or side causes. So that means that they can't mutate the value of a variable, and they can't also read from disk somewhere or do something like that. So, of course, most applications will eventually need to store state and interact with the outside world, right? So that's why MVI architecture only really borrows from functional programming. It's not a pure functional approach. Now that I've said that, though, MVI implementations will use various strategies to isolate any side effect heavy code from the rest of your more functional code. So MVI also borrows from reactive programming principles. Now, what is reactive programming? Well, it's all about creating streams of signals and subscribers that react to those signals and that shared state. Now, you see I mentioned shared state, but don't worry, right? Because in MVI, we do create components that expose streams of model state on the output side. And on the input side, we are going to add handler type functions. Now that also stays true for the view. A view will have different implementations, but the concept is similar. You have a subscription that intakes state and updates the view, and you output signals through the click listeners and handlers that you can see here. Now, the code I'm showing here obviously is JavaScript, Android, and JVM. But if we're working with iOS, we're using Swift, so that gets different. That will be a different implementation at that stage. All right. So now we've touched upon the big concepts that are behind MVI. One of the goals with MVI is to create very clear boundaries between that side effect code I've talked about and sometimes side effect heavy API code that you will get and use, and your own more abstract business logic code. So the approach is supposed to help you reduce code complexity and that's the key point here today, allow for better code reuse, right? And that's why MVI is useful in the Kotlin multi-platform environment, because you want to really on what code can I reuse between these different platforms. So context is king. And so for today's discussion, I want you to imagine we're going to build a small mobile app. So if you're like me, though, you're going to be a bit bored, right, with the to-dos app. Well, instead we're going to be building a habit tracker app. Not that much different from a to-do app, but at least not exactly the same thing. So a habit tracker app, we're going to want to have a screen where we can see our goals and track our progress. Here in the diagram, each bar will represent a habit. We're going to track different habit entries that we added to the app, and these bars let the user know how well they're doing relative to their goals, whatever they are, like drinking more water, going to the gym, etc. The top bar in this view would allow us, for example, to zoom into a given day of the week to see how we were doing that specific day. And the bottom bar would be like your basic grab bag of funky features. We'd also need a screen where we create new habits or edit existing one. I'm not going to go over that too much because this is not really a talk about implementing all these features, but it's good to frame the context that we're in. Mostly, I want you to think about the data structures that we see here on the left. So we're going to have habits that have name, frequencies, units, goals, etc. And and then these frequencies represent weekly or daily type of units, and unit types are a counter, number of times you went to the gym, to-dos, if it's a one time a week type thing, I call your parents, etc. All right. So how do we structure this multi-platform project? How does that work? What does that look like? We're aiming to build this project and target Android, iOS, and the web, let's say. So workflow-wise, it's worth sort of really getting a better idea that what the tools that you're going to be working with look like. So in this specific case, perhaps obviously for Android developers at an Android conference, right? Well, as far as like the apps go, we're going to be using Android Studio here for all our Android needs. But once you hit the common layer, right, you'd be in the right to ask yourself, okay, what am I going to use here? Android Studio works fine. You could also use IntelliJ. Like IntelliJ is an option as well. Now, one of the main reasons I wanted to touch upon all of this is that once you write iOS code, you're going to be using most likely Xcode. And you could also use app code here to code your app. So already, I just want to give people the idea that when you're doing multi-platform projects, you're going to have a lot of IDEs open at the same time. And the final point is the web. The web itself is usually something where you'd want to be working with IntelliJ, honestly. Like Android Studio, sadly, doesn't have enough support for JavaScript, in my opinion, to do a super good job. So IntelliJ is like a pretty good option here. Of course, most of the stuff you can do out of Android Studio and Xcode if you're not into paying for licenses for different software and that type of thing. All right, next up. So if we look at project configuration a bit more concretely, what would the Gradle files look like? Now, I want to say I'm not going to be going into like the nitty gritty of every little detail of a Gradle files that you need to get to work. I want to give you an idea of what the project layout looks like. The reason I'm not going to dig into the details is that effectively these types of projects, multi-platform projects, are still in beta. So your mileage might change a whole lot. And at the end of the day, if you're curious about the nitty gritty, look for the end of the talk where I'll be sharing my GitHub page for the project that backs all these examples. And that's where you're going to find really the meat of things that you need. Also in that project, I will be linking to a lot of my source material. Now, something I need to mention, like obviously we're working in a community, so a lot of the work I've been doing here has been helped along tremendously by projects like TouchLab's Camp Kit project. You might be familiar with it. If you're not, you definitely should check it out. I'll have links in my own GitHub to these other projects. And there's a few other references I'm going to talk about a bit later in the talk. Anyway, so top level Gradle file looks like this. So that's your very standard, super stereotypical Gradle file, nothing specific here, right? The one where the magic happens, so to speak, is the libcommon module. Now, you need 3 different types of plugin in this library. So you want the multi-platform plugin. That's the one that's the most important. That's the one that says this project will target common code, but also will be usable from all the other platforms afterwards. The other plugins you need are the CocoaPods plugin. That's a very important one once you want to hook up to your Xcode project, and the typical Android library one. just to be able to target Android. So first off, what you want to do is configure that Android plugin. If you're coming from Android, really nothing new here. It's super typical type library configuration. Now, the Kotlin block is a bit more interesting. So the bulk of that configuration will live in that specific block. Now, if you look, we start by defining a whole series of different platforms. The first block is JVM, which might seem a little bit odd, but in fact, targeting the JVM in Android, there are different targets. So in my case, I wanted to have a JVM project to be able to do a few tests and run some command line tools. You might not need that in your own project, but that's one that I've added into my own. I have the Android target, I have the iOS target, I have an iOS simulator target that's necessary if you want to be able to run on the iOS simulators. A JS target, so that's the typical JavaScript targeting project. That's the configuration you usually have, even if your project was a single platform project. And that's about it for that. Now, if you can have other targets in here. You can have Mac OS, Windows, and those have their own different configuration types, but that's not something I'm going to be digging into here. The next segment that is important to know about and to be aware of is, so that's where you're going to be defining all the different source folders that your project is going to hold and where you're going to be putting your Kotlin source code. No definitions for Swift. That's something else. That's a different type of project, right? But here we're only targeting the different platforms with Kotlin code. The common main and common test are the main ones that you need to pay. So anything that's here, all the dependencies you might be adding in the common main and common test are dependencies that effectively will carry over to all the other platforms. And so it's important to note that the dependencies you're going to be putting in there are dependencies for Kotlin multi-platform projects as well, meaning that, well, we'll talk about a few of the libraries that are multi-platform to start with, but that's where those are going to go. And all the other source sets will be inheriting from that and will allow you to use the common code in platform-specific sections of that library. Right. So closing off the whole super fascinating Gradle setup, but it's still important to talk about because, believe me, multi-platform projects, you're going to be spending a little bit of time in there. The CocoaPods section. So that one's kind of important because it's the one that will allow Gradle to make the bridge with Swiftland effectively. So CocoaPods, if you're not aware, is a dependency management system for iOS. And so it kind of brings the same setup that we're used to in Gradle land and Maven land, where you can list your dependencies and import libraries and so on and so forth. That's not something that iOS had for the longest time. CocoaPods is one of the two most popular solutions that are out there. And so what we're doing here is that we're defining what our own library will look like from the iOS side, and it will be exposed as a CocoaPod dependency to the Swift project. All right, so how much code reuse can we actually expect from this project structure? I've touched on the code reuse chart earlier, and I gave you the breakdown of what you can expect. But if you think about it, ultimately, right, well-written model code will land in the common section. That's the goal. That's the gold standard. If you could put all your business logic and your model logic into the common layer without having too much trouble, you're basically a winner. That's effectively what it is. Every other module, though, is effectively one-time use. So ideally, you want to be looking out for any type of code you think that could be made generic and bring that on the common side. And effectively with an MVI architecture, it'll be simple enough. It'll all be model stuff. Now, that being said, let's see exactly how much of that code is going to be shared and start looking at some examples. So first off, your model is going to have states and data and things like that. So all that type of content and of code obviously is easily shareable and should live in the common library. So in our case, for a habit tracker, we're going to have habit and entry data, and that will be bundled together in something that's called habit state. So habit state is not the basic pieces of data, but it's going to be the state that our models is going to store. Our model is going to store. So all of that type of code obviously lives very well in the common layer. In our own app here, we're going to want to keep an in-memory cache of a user's habits and entries. It's a bit of a naive approach, but it works very well if you don't have a ton of data. Now, it's clear that, it's clear for all that has to do with data. Now, we have to look at the model's logic. How much can we expect to put of that model logic in the common module? Can we make most of it platform independent? We're going to find out. So first off, we need to think about what interfaces and what our model is going to expose to the view. So we're going to use stateflow to build the habit store. Stateflow is effectively our model's output, right? Now, coroutine and flow support is something that's available multi-platform wise, and that's a really big deal because stateflow and coroutines allow you to publish your model state to views in a safe and consistent manner, and you're going to be able to put a lot of the meat of your code in those modules because of that. If we didn't have coroutine support as a multi-platform feature, we'd be in trouble. On the input side, MVI typically exposes one or more intent processing function. So it depends a bit on the approach that you pick. My MVI approaches are handmade, or if you will. I don't typically use MVI frameworks or libraries. So in my case, I expose oftentimes a function called process that takes an intent, and that will operate on the model and change its internal state, which will eventually get published. Now, depending on your MVI approach, you might want to create an intent builder type layer. So in my own code, that often looks like a dispatcher that takes view events and converts them into intents. Very often that dispatcher is functional in the sense that it's not an object with an instance that will process things. It's literally a collection of functions, stateless functions, that take a view event as an input, output an intent, and somebody would take this intent and feed it to the model. Now, depending on your approach, you might decide to do something a bit more like what I've been doing a bit more lately, which is instead of having a very generic process type function that takes all types of intents, I've started lately to define my processing of intent functions directly into my model. I found that it actually works pretty well, and it makes my models easier to use and easier to reason about in the context of the views. So that said, when I'm building an MVI model personally, there is one thing I feel pretty strongly about, and that's something I call intent validation. Now, the idea is basically as follows. So to validate that an intent is valid, repeating myself a little bit there, but what I usually will do is build a state machine of some kind. Now, in this case, the state machine is represented by the attribute cache state. So cache state here, it helps us validate that each of the transitions, each of the calls to the different process methods are actually valid and not out of bounds. So for example, in the case of our model initialization, right, when we're starting out here, what you want to be doing is you want to start off by loading data from the server. So by having this state here that's loading, what you can do is that if anybody outside, if a piece of the view, for example, forgot to disable a button or is not like necessarily well connected to the model, if the views try to, for example, I don't know, to launch another load command while the model is loading and is in that state, by knowing in which state you are, you can actually react to that and say, oh, I will actually drop that command. I will not execute that intent. So if I keep going a little bit with the logic of our app, we'd have stuff like once we've loaded, we have a success state. So we make a call to a web server, it comes back, things have worked, we'd end up in the loaded state. Potentially users will start adding habits. And what we can do in this case is any type of CRUD type method will yield a state that's busy. So that means that the model, when it launches a request to the server, for example, to update data, what it can do is just to stay in this busy state and effectively start refusing any type of weird attempts to do more work while the current piece of work is not yet resolved. It also allows the views to say, hey, we're busy right now, and just show a spinner, right? So this is important for coherence, and this idea comes back a lot in most of my model work. I found it invaluable to effectively catch bugs and make my own applications pretty much bulletproof. Now, there's more to this, but I'm gonna keep going. Like, you get the picture. So to enforce a state machine, it's useful to look at what exactly type of code that is built for that. So here you see that we have a function, sorry, called valid process. So what this function's work is to effectively take a predicate, so a function that will look at the current state and, being aware what you were trying to do, be able to say, no, we're not going to do this, or yes, this is work, this piece of work is fine. And then the intent itself that we will process if the predicate passes the check. So below we have the function is reloadable. That's our predicate here. Is reloadable will take the current state and will basically tell us, are we in a modified, failed, or loaded state? And if so, then yes, we can allow a reload command. Otherwise, no, we can't. And in those cases, what I've typically done in my apps is I silently drop the command. I silently ignore this command, and that's all I'm doing. Another option is to simply crash your app, but that's slightly aggressive. And there's two philosophies around that. You might want to catch all the errors as soon as you can, but then the other philosophy is, well, if it's a runtime type of problem, you probably don't want to crash your app in case somebody made a small mistake that's hiding in a corner of your app, right? So it really depends how much testing you have and what your company culture looks like. What else is there to say here? Well, another thing that's kind of interesting is that, yeah, that's about it. I'm forgetting something, but that's fine. I'll probably come back to me in a second. All right. So another big cornerstone of my MVI projects within the multi-platform mode is the Ktor library. Now, what's fun about Ktor is it allows you to use REST calls pretty much multi-platform. I'm typically a big fan of retrofit and OK HTTP, but if you're on JavaScript or if you're on Swift and iOS, you can't use those yet. Like, maybe eventually we'll see a port for those libraries. But meanwhile, Ktor does an excellent job at providing something to the level of retrofit as far as like simplicity goes and everything else. So here I have a small code example. You can see that I've defined a habit API interface. So if you compare it to something like retrofit, the footprint is pretty similar. We're just saying basically what type of parameters we're getting. I have a little type response class I created myself that helps me deserialize the information out of that request. We just give a path. We do a simple get call. Things are pretty straightforward. And when you call that from your habit model, you can see here in the habit code that there's not a whole lot of voodoo going on. You just make your call. If it's successful, you do something. If it's not, you do something else. So nothing too funky going on here. Right. So I'm looking at time a little bit. I don't want to go over. So we should be good. I will pick up the pace a little bit though. So now it's time to look at the view code, the so-called single-use code that we've been talking about. Now, for Android, as you might expect, if you're, again, an Android developer, as you probably are, Compose is the way to go. Compose is really awesome in the MVI context, basically because of the unidirectional data flow approach that we're taking. Now, I think it's worth explaining a little bit, like looking over a little bit this piece of interface right here. So, well, yeah, like effectively you can see that we have a fairly standard Compose builder. So Compose allows you to declaratively build your interfaces, which is like one of the main key pieces. But what I want to focus on here more is a couple of concepts. One of the ones that we don't talk often about, I think, is the idea of internal UI state. So That might be a little bit controversial to you, but if you think about the MVI setup and the functional approaches, in our models, we have internal state to the model, and those models publish that state in an immutable manner so that anybody that's interested can react to that and effectively update themselves. We're talking about views in this case, right? And then when you want to apply changes to those models, you have a very clear interface to go through. Now, views, there's nothing that says that views couldn't have their own internal state that the models are not interested in. So if you think, for example, about a form effectively, you could build it as a compose function with its own internal state for the fields and only submit that data to your model when somebody presses save, right? And that would be a pretty reasonable use of internal state for a view. Now, what's fun with Compose is that they embraced this concept, and they even offer facilities like, for example, saving those pieces of state automatically for you and restoring them when the app comes back online. So if you have like a configuration change, well, Compose has the facilities to basically serialize that data to disk and bring it back. And all you have to do is use something like this here, remember savable. So that's a pretty neat feature. Another thing I want to point out about the Compose approach and how it marries itself fairly well with our MVI stack is how we emit events, view events, back to the model. So what we have here is a handler in this function right here. So that handler is all we need to worry about. Like, we basically pass something in. The Compose view doesn't really know what it's calling, but it is emitting those events. And so by connecting these handlers up top to our model, Compose doesn't need to know what's happening, but it can easily signal everything that we need to signal and to trigger events on the model. Like in the past, before Compose, this is actually a bit more complicated. In MVI stack, it would involve handling your own stream of view events and connecting those to some sort of translation layer and using a dispatcher like I showed you earlier. So what's interesting with the new declarative UI paradigms that we see both in Compose and we'll see in a second with SwiftUI is that it's very easy to connect these things to your model. And another very, very easy piece of work is that once you look at the input side of things, in Compose, all you have to do is to pass in something like this habit state into the composable view. And now we have no streaming involved here, right? Like, that's done from the top, but Compose is smart enough to see when pieces of information change and to smartly call the right pieces of the view to update it as needed. Right. So other things to look at. So subscribing to Stateflow, what does that look like? So if we go back to the top, like we're at the top on where before we call habits view, it's very, very simple. You take your habit model, you take the habit store that's inside that model, and you call a function called collect as state. That's a Compose function, and that's the function that will look at the input stream and intelligently hook everything else up to your Compose views. Then we have processing intents. That's a little bit more involved because there's a little bit more code, but really it's not that complicated. All we have to do is call a when on top of our event and dispatch the event to the right piece of code. Now, you can see that if there's a create habit or edit habit here, we would call a nav controller, and that's effectively does not involve the model at all, and that's a really great thing. With Compose, you can set up your own navigation structure and not have to bother with representing that on the model side at all. That's another thing in the past when I was doing MVI without Compose. I often ended up having to track my own nav stack in different ways, and that was usually a pain in the neck, quite honestly. So with this, with Compose's own sort of internal state management, its own internal way of doing things, you can really isolate the UI behavior from the model behavior and do a really nice division between the two. If you look at the add habit entry and the undo habit entry, that's when you would typically call your model, and here we're calling those process functions that I showed you earlier. So fairly straightforward hookup between these different types of things. All right, I'm looking on time, and I don't want to stretch on too long. It's the first time I give this talk, so it's always a bit of a challenge to hit the time box in the proper way. at this point, what I wanted to show here is effectively that when composition becomes more complex, you need to think about unneeded recompositions. And that's something that comes back in all the different view systems. So I will spend just 5 seconds on this here. The idea is that when you have your stream of data that updates, so if your habit state changes, a piece of change, you don't necessarily want to trigger a redrawing of the whole view system, right? And so even though Compose is really well built to target those specific zones that have changed, you do need to keep an eye out because it's possible that to fake out Compose and to not let it do its job properly. So that's true also with SwiftUI and all the other frameworks. I found that it's very important to keep an eye on the different stacks and tools that you can use to profile your program and look at what's actually efficient or not, and then adjust your approach accordingly. All right. So we're gonna very quickly touch on the other platforms. So the one I have the most experience with alongside Android is actually JavaScript. Like I've played with this for quite a while, and I had good results sharing logic between JavaScript web projects and Android native projects. Another key cornerstone that's quite useful here is a library called Kotlin HTML. This is a library that allows you to build DOMs on the fly. It's available multi-platform, although in this case, I've only really been using it for JavaScript and web apps. I stopped sharing, or sorry about that. Oh, I see what's going on. 1 second. All right, we're back. There we go. Okay, so Kotlin HTML allows you to build your own DOM and generate your web page effectively. So here it's a small example where I would build a page with a title header, some content rows, and at the bottom a control div, something very similar to the Android app I showed you a few minutes ago. That control div, I made it much simpler. There would only be a new habit button and a settings button on there. At the bottom, I have a main div, and that typically in my view classes on a web project would be exposed as a public attribute. And that main div combines everything together and just builds that view component that can then be added to a web page by a top controller somewhere. Now, why do I take the time to split things up this specific way? Well, it's because the title header, content rows, and the control divs, to some extent, you're going to want to be able to update following a model change, a model state change. So the idea is as follows. Like, this is typically what my views will look like on a web project. I inherit for something called a view component, which we'll take a look in a minute. But the important code happens in attach. So when the view is done building and that the models are ready, we attach the view component to both the state flow, so the state flow coming from the model, that's our state store, and we also attach it to handler functions. Now, first off, the state flow. The idea is very similar to what you've seen for Android. Is the idea that every time there's an update, you want to clear the screen and update the different components. So in this case, that's why I split the view up in this specific way. I want to be able to change the title header. So I need to have an addressable, effectively an addressable attribute to be able to say, okay, clear yourself. Here's your new content. Same thing with the rows. I clear the rows, I redraw them. So it's a bit of a brute force type of approach. But if you start looking, and that's what I found, like when I start profiling this stuff, it actually is fairly efficient. Another option, if you're more into this, is that you could use the React stack on the web and connect it with Kotlin.js. There's a lot of documentation out there in the community. A lot of people are doing this. I personally actually found it a lot simpler to just roll my own approach, just like this here. What else is there to say? Well, the event handling is a pretty important part of all of this. And it's fairly simple, but it is worth spending a second on it. So in my own views, what I typically have on the web is an events shared flow, as you can see here. And that events shared flow exists when you build the view. Your own view components, your DOM will target it when they need to emit events. And the reason that's there is that you can build your view and you can funnel all your events into this shared flow without necessarily having connected to the main model and things like that. So you connect to the main model when the main model has been built, and you can still build your views independent from it. So that's how you make that little connection. Also, the reason it's a slightly different approach than what you would see in a native app is due to due to side effects that you will get from JavaScript effectively only having one thread. Coroutines do work as expected, which is like a very pleasant surprise when you start out. But it does require you to be aware of certain little maneuvers you have to do not to deadlock everything in certain cases. There's a few things that are not as intuitive. So anyway, my own solution for these problems has been to hook things up in this specific way. Yeah, long story short, now I'm going to skip over in the next little bit of the presentation. I'll finish at least the view side of things with this view component. On the web, this is how I've been sort of handling things. So it's a very standard coroutine approach. You have a little job, you have a coroutine context that you can get your job from. You can cancel the job, so everything else that's hooked up under that specific coroutine context will get cleaned up nicely when you call detach. And that's mostly when you have different view components that you want to add or remove from the screen, right? If you're just talking about a regular web page, when you skip to the next web page, the detach per se is not necessary. But if you are reusing view components and building dynamic pages, then you do need to think about that when that component might be disposed of and something comes back and things like that. All right. Well, I'll be skipping quite fast over SwiftUI and everything else for the simple reason that I'm still personally working on that. You'll have the link to my own Git repo to benefit from all my work when I feel more ready. As it is right now today, I did not feel very confident in presenting this as an authority on the subject. SwiftUI, though, very nice library. What's worth saying is that it's very similar in functioning to Compose. It's also a declarative approach, so you'll be in very familiar territory there. What does change a fair bit is how you hook up SwiftUI to your Kotlin stack. And that's where actually I've been challenged personally. I've been following this article that's really super interesting by John O'Reilly that I recommend you check out. And once I've actually applied the lessons from this article properly, those will be available on my GitHub as well. Now, the other segment of things is to consider what's the stack underneath. So you have SwiftUI, and they have something called Combine, which I would want to say the closest equivalent to on Android and in Kotlin is your flow, not necessarily your coroutine, but more like your flow of unidirectional data. So the article about John's article is all about hooking up your Kotlin native flows with the Combine framework and making that work nicely. So Combine is the API you're going to want to be looking at if you're working on that angle of things. Now, I'm going to try to quickly wrap up. I think I'm past the 40-minute mark. Coin is the glue that holds everything together. You have a few choices. Well, you have at least one other choice that I know of as far as like your DI systems go. So you have Coin or Codeine on Kotlin that are multi-platform DI solutions. They're not as sophisticated as Dagger and Hilt for the simple reason that a lot of your DI problems will be runtime DI, in the sense that you can't at compile time detect missing dependencies and things like that, something you can do with Dagger. But Coin and Codeine have pretty nice approaches that if you back your things with test, you'll have about the same kind of coverage, if you will. And they work multi-platform, so that's really nice. They bring you all the goodness of DI for all your platforms. In the case of Android, what does that look like? Well, if you've worked with DI engines before, this is probably familiar enough, but nothing super complicated. The approach is pretty simple. I'm short on time. So I will skip ahead to other platforms that are worth looking into if you're interested in multi-platform development. So Compose not only is available on Android, but will be and is sort of available on web and is available on desktop. Now, I say sort of because I've tried as much as I could to make Compose work nicely with my JavaScript projects, but as of today, I feel that I can't really recommend it. They're still very much in beta, and the language starts behaving really weirdly because you have another compiler involved whenever you're working with Compose on the JavaScript side of things. On desktop, from what I've seen, I haven't played a lot with it, but it's a lot better behaved. So I think that's really, if desktop clients are your thing, you should check that out. Firebase is actually a very interesting one. I included in this talk. I just mentioned it in this talk for the following reason. Firebase has different platform APIs. Like they're totally, like you do not have a multi-platform common approach to Firebase. But what I found and is super interesting is that when you work with Firebase, you do get streams of data available independent of the platform you're using. And so I found that my own code when using Firebase, my model code is a lot simpler. And by connecting through DI implementations of Firebase layers, that my model code would be a lot simpler. And I mean, anyway, it's a very powerful tool system. And that's something I'm hoping to showcase in my project as it gets a little bit more built out, which hopefully you will follow it and go see. But before I give you the link to my GitHub, I want to mention that if you're more of the I want to follow a framework by people who have built out a lot of nice work already for MVI, then I recommend you check out MVI Kotlin or Orbit MVI. Those are very good MVI frameworks. As far as I'm aware, they're also very multi-platform compatible. I'm more of the minimalist school approach, also because it's easier to explain things when you don't have to basically follow a prescribed approach. So you can simplify a whole lot. Whereas I feel like with these frameworks, you have a lot of rules to follow. And sometimes, you have to explain those in the talk. So that's a bit less practical in my mind sometimes, and also practical at use, but that's a personal choice. And I want to finish this talk. Well, I've talked a lot about technology, and I want to close with basically why should you pick a Kotlin multi-platform approach, say over something like Flutter or React-Native? And basically, it's the idea of the T-shaped learning that I want to promote today in closing. The idea of the T-shaped learning is that a T-shaped specialist is somebody that has both a wide view of the field and is highly specialized in one vertical. And so what's interesting with Kotlin multi-platform is that any level up of your Kotlin skills that you bring to the table will benefit you across a very wide range of system. Now, it doesn't take away the fact that you have to be a specialist in certain things to ship Kotlin multi-platform code. And what I mean by that is you need to have, if you're a bigger team and you're shipping bigger projects, you're going to need to have iOS specialists on your team. You're going to need to have JavaScript specialists and people who are really well versed into what is the web environment like today and the web ecosystem is like today. You're going to need specialists in Android development, like most of the audience here today. And potentially, if you want to target backend stuff, you're going to need people who know their stuff about backend and how to scale systems. So what I find interesting with the Kotlin multi-platform approach is that you can take Kotlin as a base language and take a whole lot of specialists and people who have very different points of view on effectively app development, and you can sort of teach them a common language. So I feel like that's a very promising approach, and I hope that you will also feel this way. And with this, I want to say thanks. Thank you for watching. It was a pleasure to present. I hope that you will have been entertained, interested, and if you have questions, I don't know if we have time for questions, but I will be happy to answer them either here now or on this following GitHub. If you want to go and follow this and ask me questions through issues, and I will very likely, if not already activated, be activating the discussion module on this Kotlin, GitHub project. So I invite you to go and be part of the conversation there if you're interested. With that, thank you very much.
I miss our previous platform actually had people would click a clap emoji and it would pop up at the bubble up at the bottom of the screen, and it was very exciting. So best I could do is like a live clap. As I'm sure other people are. Yeah, I can see other people are clapping.
Well, thanks.
Um, Etienne, thank you for that. I think it was a very solid intro to Kotlin Multiplatform, and I feel like a lot of the time we tend to see talks that focus more on the KMM side, so just iOS and Android. So it's interesting to see the addition of like, also you could also just do the JavaScript side.
Yeah, it's something that we often neglect, but the web is like such a huge piece of everything still nowadays. So yeah, I find
I
it
feel
interesting.
like Android developers, like, we already have an issue with iOS developers thinking they're better than us. But then, like, you factor in, we were talking earlier about how you came from Shopify and they did the whole switch to React Native, and it's like, well, then above who who we think is condescending to us above iOS is then the web devs. So of course, if we're barely considering KMM for iOS, we have to ignore the web.
Yeah, for having worked on all the three different sides of the equation, like I find that, isn't it just better when everybody just gets along? So yeah, that's why I like Kotlin so much. You can use it everywhere.
It is wonderful.
Yeah.
I'd say Ryan and Mohit. So Mohit's the next speaker. Ryan's the host. They said that it's cool for us to start the Mohit's talk a little later. So you're welcome to go through some questions, folks. If you want to add yours in or upvote the ones that are currently there, please do. And then we'll take a 10-minute break afterwards.
All right.
Yeah.
Yeah, I went way over, but then yeah, like I was saying, first run of the talk is usually when everything just spills out. Okay, so I'll look at the questions right now. There's three, so we should be able to go through those fairly quickly. First one, Marion, is there an archetype or command example for building KMM project with Gradle using the command line terminal? Not that I know of. Uh, like the what I do want to mention is that the CocoaPods approach actually generates like a fair amount of stuff for you. But as far as I know, like I might be wrong there, to be honest. Like I'm the person that handcrafts everything, and it's a bit annoying, to be honest. But I'd like to find out if it's not the case. Although what I can say is the CocoaPods side of things. If you look at the CocoaPods documentation, because something I barely touched upon with the time going over there, but the Swift project that you have in your KMM project is entirely independent, pretty much, right? Except for that connection with CocoaPods. But then the CocoaPods file that is generated by the CocoaPods plugin in Gradle, yeah, well, that's not exactly accurate, but you can build an equivalent one for your Swift project, your iOS project, and that will build a lot of stuff for you on the command line. So that is one thing that you should look into. It's been a while since I touched that. So, Gabor, how do you ensure a multi-platform way that users' inputs stay alive across Android low memory conditions, like you would on Android with view model and state save and get state flow? So I want to make sure that I answer this question properly. So, right. Well, okay, so there's a couple of things in there. First is your model, right? And then second is Compose. So as I showed very quickly, Compose has this really nice DSL that allows you to mention that its own internal state, the view's internal state, will stay persistent across the app, right? So that's one side of the equation, in the sense that for me, like what I had as a problem that kept coming back with like the old school way of doing the Android approach with bundles and everything, is that your views sometimes would not not serialize to disk properly, and you'd lose state in the text fields. Well, we're talking like eons ago now, but that type of thing I find is extremely annoying and to deal with. And then what's nice with Compose now is that you can have Compose, say if you imagine a form, right? You're editing a form, you have 3 or 4 text fields, the user's typing into those, there's a config change. If you're using that remember savable DSL I showed, then that side of things will stay in place. Now that's interesting if, for example, your API that you're working with, your model is a model that expects a transactional type of approach, meaning that a bit like a web form, you're filling out all the fields and the models are staying put there, not doing anything until the user presses save. When you press save, the model itself will update itself, call the server, potentially save itself to disk if it needs to, right? And that's the second part of the equation. So the first part of the equation, the views, the text fields staying up to date, if you rotate and all of that, that's taken care of for you with Compose. There's equivalent things on iOS, and on the web, well, that's a bit of a different story, right? But like, I don't know that users really expect to survive, say, closing a tab and coming back, which is sort of the equivalent in the web world of what we have to live with on Android. But effectively, on the model side of things, if you only build your model to be an in-memory copy and that it's going to be, say, saving the transaction on the server, right? And say the user shuts down while you're busy waiting for that transaction to save. You don't necessarily know what happened. You don't necessarily have your model up to date. But in the specific case of a model that's representing an in-memory store that works that way, then you don't actually care. Like, meaning that if the transaction went through and your app is killed and you're coming back, the app coming back will reinitiate itself, in my specific example, call the server, get fresh copy of information. If the transaction went through, that state will be consistent. If it didn't go through, the work was lost. That's terrible. A better approach, if you build your models a bit more solidly, is to perhaps save on disk the transaction and do a retry process and things like that. But at the end of the day, it really depends on what system you're using. If you have an in-memory cache, that comes with certain challenges. If you're using Firebase with a local copy stored, Firebase actually will store whatever transaction you're trying to do in certain cases when it's configured properly, and retry that after process dev when you're coming back. So it depends, but I feel like that might answer a little bit of that question. Like, there's different approaches you can take, but you do have to think about it. At the end of the day, it's always the same story. Okay, sorry, that was a long answer. The common library you explained also contains a data source layer part of the application, or just a model data layer? Both. In my specific example, we had the REST calls, like the REST API and everything was defined in that layer, and that's through Ktor. So if you're using retrofit, sadly, that doesn't translate very well. You'd have to, if you have an Android project that's using retrofit right now, you'd have to retrofit your retrofit code to make it work with Ktor, which is something I've had to do in a few of my own examples, and to bring that back to the common layer. If you're using Firebase, as I was sort of citing during the talk, Firebase has libraries that are platform specific that sort of live higher up than the common library. So what approach you have to take then is to basically define an interface that's common to Firebase, independent of the implementation, the physical, the platform implementation. Call that through your models, call Firebase through that interface. And then with your DI engine, you would have to provide the proper implementation of that interface to your complete system. I hope that makes sense as an answer and that's clear enough. But effectively, you can definitely get away with putting your repository and your business logic layers in the common lib. But again, it depends, depending on the library you're going to be using and the other frameworks you might involve. Chuba, it seems you have to learn different programming languages to make this work. Does this get in the way of productivity? Yes, potentially, right? I mean, am I going to be as efficient an iOS developer as I am an Android developer? Absolutely not. Is it possible as a small consultancy to actually ship apps, multi-platform apps? Yes. And the reason I say that with a fair amount of confidence is because certain things on iOS are not that complicated. Like, if you want to build views and really your business logic is something that you've already built and is coming from somewhere else, as long as you've built the glue once, you're not going to be bothered with a lot of that. So in a sense, your Kotlin skill set does transfer, let's say 40% the way through. If you're building a big team, can you get away with having nobody that's really somewhat specialized in iOS and Swift on your team? You won't get away with it. Like, you still need the specialists. If you don't want the specialists, and that's not where you're looking for because your company either can't afford it or you're not actually targeting the fine-grained, super specific features of a platform, then React Native or Flutter might be a much better choice for you. So again, it depends what you're looking for as a team. All I can say at the end of the day is that the teams I've worked on that were the most efficient weren't shy about having a few specialists on board. What's important is to find a way of making all the specialists work and talk to each other. That's not necessarily a language problem. It's more of a team culture problem. But if you do have that common, say, Kotlin layer that everybody can sort of focus on when it comes to business logic, I think it just turbocharges that sort of communication very nicely. So last question by Anonymous. Is it possible to use an IDE like VS Code to work on a multi-platform code base? I feel like I've heard people do that. Yes. But I'm more of the school of having all the IDEs open. So I typically, when I do work on a multi-plat project like that, and I have an iOS component, you're going to find me with Android Studio, Xcode, and AppCode open at the same time. Like Xcode is really good at letting you see the SwiftUI previews, but I can't code for crap inside of Xcode. So I'm very used to the IntelliJ type shortcut. So AppCode, I'm just so much more efficient typing code in that I will have that open. And Android Studio, obviously, because if you're writing Kotlin, then that's a plus to have that there, obviously. And even same with the web, I'm going to have like IntelliJ open. So to be fair, that makes my machine kind of slow sometimes. So that's the real downside. So if VS Code would work for all of those things, I would definitely think you should explore that a little bit. I'm just not familiar enough with VS Code to tell you if that works. That's it for questions. I'm going to quickly just say hi to people. Thank you, everybody. Very happy to have shared stuff. So if you want to reach out, I am somewhat responsive on LinkedIn. Your best bet is really to just start chatting me up in the GitHub project, and I'll be happy to interact with you over there. I'm happy to interact with you everywhere, but you'll get a quicker answer if it's from that place. Thanks again. I'll say goodbye to y'all and hope to see you next time. Shalom, you're the one that shuts down this channel, right?
I am. Thank you, Etienne, so much for answering all those questions.